Okay, so in this part of our lecture, we're going to cover the Python package called NumPy. So NumPy is the standard go-to Python package for numerical computation. Anything that has to do with linear algebra will be done with NumPy. NumPy is highly optimized and it's really fast, considering it's inside of Python, because Python has a reputation for being slow, but Python is highly optimized and can be used for all sorts of scientific computing and numerical linear algebra and PDEs and things like this, and even statistical operations. So it's a must know for any data scientist that's going to do any machine learning. And I encourage you to go back and read this description after lecture. Okay. So we're going to start with the basic type in NumPy, which is the ND array. And ND arrays are, again, it's the most basic type in NumPy, and it's what you will see most often. So to create a ND array, actually, I should probably mention, you import the module NumPy as MP. That's the standard way of doing it. So what this is doing here is it's importing this object. In every object, I mean, everything in Python, so I'm jumbling my words. Just remember, everything in Python is an object, and objects have methods and attributes. This is a package, but again, everything is an object. So we're importing this package and we're giving it this name. So this is the object we're working with. Now, objects have methods. One of the methods that this package has is called array. An array takes as an argument a list and converts it to a NumPy ND array. So let's go ahead and run this code and see what happens. Okay, so we've imported NumPy with the alias MP, so we don't have to type NumPy over and over again. This is just a shorthand way of writing NumPy. And then we assigned the variable A to be this ND array, which is created by calling the array method from NumPy and then passing in this list. So this is our ND array right here, and then it's of type NumPy ND array. Okay. So now A is a ND array, so it has methods and attributes attached to it. So two of the methods that you should definitely know about are the shape and the type, the D type. So notice here, A, I'm instantiating with the list 1.0, 2.0, 3.0. And then here I'm instantiating B to be the ND array with 1, 2. So these are integers and these are floats. Okay, so let's look at what happens here. Okay. So here, the shape of A is 3, and there's nothing there. This is similar, but not the same. This is similar to a 3-dimensional column vector, but not the same. It's just similar. And that's how I think of them, as 3-dimensional column vectors. And the type of this, the D type of this ND array is a float 64. The shape of B is 5, nothing. So you can think of this, think of it, but remember that it's not the same. Think of it as a 5-dimensional column vector. And it's of type int64. So unlike Python lists, NumPy lists they contain the same type objects. So for example, I can't throw a string in here with these numbers. It will throw an error. They have to all be the same type. And again, this has to do from a computational speed perspective, like that these need to be the same type for the algorithms that you can implement on these objects. So if you're wondering if you can mix integers and floats, you can. So for example, if I just put a 2.0 there, it now defaults to float 64 because there's at least one float in there. But if there's not, and it's all integer, it'll say integer array, ND array. Okay, so these are attributes, just like we covered in the previous video, right? Every object has attributes or data associated with it. Now, onto the methods. So there are tons of methods on ND arrays. I'm just listing a few of them that might be useful early on in this semester. So we have the mean method, max method, argmax, min, and argmin. So let's just go ahead and see what these methods do. You can probably guess what they do, honestly, but let's see. So here is our nd array. Those are the entries in it. Okay. The mean of these values we can calculate with the mean method. Super fast and convenient. The max is this, right? Now, this is much faster than the built-in Python max function. Like we could, for example, do this. But this is going to be much slower than calling the max method. So remember that when performing computations or designing your algorithms or writing your algorithms. Okay. Next up, we have a very useful one called argmax. So this just returns the index of the maximum value in that nd array. So if I look to the index 4, I see so 0, 1, 2, 3, 4. So that's the associated index 4. That's the argmax. Min gives you the min, and then the argmin is also the index of the minimum value in the array. So if I go to the index 2, 0, 1, 2, this is the minimum value in that nd array. So as I have mentioned before, nd array types behave similar to, I think of them similar to column vectors, even though they're not, I have to say that again, they're not, but they behave similar. And as such, these nd arrays obey similar scalar multiplication and vector addition properties. So for example, if we have these two nd arrays, then we can multiply a by 3, and then it will multiply each entry in that array. That's another difference between this and Python lists, right? If you recall a previous lecture, we can add them, which is going to add element-wise, and we can also do linear combinations of them, okay? So we just copy this and take a look. All right, there we go. All right, so hopefully that all seems pretty natural. We're starting to get into more mathy things now, which you should be excited about. So nd array types also support vector dot products, right? So this is just the element-wise multiplication in sum of the entries in the vectors. They have to have the same size, but there we go. This can be done in two different ways. You can use the dot method, the NumPy dot method. So this is a NumPy method, not an nd array method. In this method, you pass in two nd arrays of the same size, or you can use the at call. So this at symbol here is going to do the same thing as the dot product between these two nd arrays. You'll see that I prefer to, at least in the past, I prefer the at symbol for the dot product. But if you want to be very clear with your code, I think that using the NumPy dot method is clear. It tells you what's happening. It's you're taking the dot product of these two vectors. So, okay. So now we're going to actually try to represent column vectors and row vectors using nd arrays. Now, before I said, yes.
Is there any way to do the cross product? Is there like a cross?
Yes.
Oh, okay.
But you'll see the link in this notebook for, I'll provide a link in this notebook for that documentation.
All right, thank you.
Right, we're just covering the bare minimum needed to go ahead and jump into data science right now. But yeah, I'll let you know after class as well. So next up, we're going to actually try to model column and row vectors using nd arrays. So we can do this, for example, we can model a column vector by taking an nd array and setting its shape to be a column vector shape. So previously, if we looked at the shape of A, well, actually, I'll just run this code, you'll see it. It was, for example, 3, comma, nothing, right? That's what it said, right? So this variable A, nd array, originally has shape 3, comma, nothing. However, if we set the shape equal to the appropriate size, the dimensions, we get that it has shape 3, comma, 1. Those are the dimensions of a 3-dimensional column vector. And then also notice the appearance. It no longer looks like 1, comma, 2, comma, 3. It looks like braces 1, like brackets 1, comma, brackets 2, comma, brackets 3. So this is indicating that it's behaving like a column vector. In a similar fashion, we can make a row vector. We just have to set the dimensions to be correct. Okay. So if we want a 3-dimensional row vector, the shape of it better be 1 by 3. And we can see we start with this original array here as before. The dimension is 3 comma nothing. But then if we change it, we get this row vector. And we see that inside of this, so look at the outside brackets, right? Open bracket, close bracket. Inside, there is a single row of entries. Hopefully that makes sense. Like this is a row inside, whereas above, we have bracket, and then this is a row, this is a row, this is a row. So that means it would be a column vector with 1 entry in each. Right. So hopefully that makes sense.
I have a quick question.
Yes.
So is there any specific advantage of reshaping it to 3 comma 1 or 1 comma 3 as opposed to just leaving it blank?
It will be necessary at times when you're performing matrix vector multiplication to make the dimensions match up correctly. Because if you recall from a linear algebra course, you have to be very careful when you're multiplying a row vector times a matrix or a matrix times a column vector. And you have to enforce sometimes that they have the correct dimensions. And there's other ways that we'll see how to do this, but I'm just showing you the basics of how to set the shapes.
Okay.
And speaking of, next up we have matrices. So if you look at the above output of the row vector, you see we have a single in the array inside of brackets. So this is indicating that this is a row inside of this matrix in a sense. So suppose we want to make 2 rows, right, with 3 entries each. Then we would pass into the NumPy array method a list where each entry is another list. And the sub-entry lists are going to represent the rows of that matrix. So if you're looking at this, this should be a 2 by 3 matrix. So 2 rows and then 3 columns. Okay. And this code that I have for you here in the notebook should kind of illustrate to you that's the case. So we define our matrix. This is what it looks like. It has shape 2 by 3, as I said. Now, if we want to access the 0th row of that matrix, we say A bracket to open bracket 0, and then every column denoted by the colon symbol. So the colon symbol denotes every column. Close off those brackets, and this returns a single row. We want the 1 row, same thing, 1 row, comma, every column, and it returns this. If we want to look at the 0th column, it's the same thing, just in reverse. Every single row, 0 column, and that's this array here. Every single row, 1 column will give you this array. If we want to access an element at a specific index, it's as easy as you would think. Just pass in the appropriate index. So if I wanted that 3, it's at row 0, column 2. So row 0, column 2 gives me the 3. Okay. Now, if we're dealing with matrices, more often than not more often than not, that's bad wording. We will have to transpose matrices every once in a while. So that's built in with the in the array transpose method. All right, so this code is just creating an instance of the of a matrix A, and then I'm making the variable B assigned to its transpose. So let's see what this looks like. Okay, so this is the same code as before, but now the transpose is B, and we can see that this is indeed the transpose of that matrix. Again, the rows become the columns become the rows.
Excuse me, I have a quick question.
Yes.
So typically when we do methods, or at least how I've seen them, we have like the empty colon, or sorry, the empty like parentheses afterwards. Why is that not the case for like this transpose method?
Oh, that
convention,
like, good catch. Good catch. I must have misspoken, because if there's no parentheses there, then it's a attribute. It's a data. It's a data value for that matrix. So I suppose when we're defining in the arrays, one data attribute of that instance is its transpose.
Okay.
So good catch. I'm really happy you said that. Okay, so that is an attribute, not a method. So, okay. So now, what else? Random numbers. So data scientists and machine learning experts have to deal with randomness in order to model real world problems, because a lot of data that you take in essentially behaves randomly, especially, for example, in like financial price data. It's essentially random. So the way that you can learn to study these things is by generating random numbers and running your algorithms on them to see if you can somehow gain any information about these sets of random numbers. And NumPy, so NumPy has a random module. So inside of NumPy, there is a sub module called random. And that random module has its own methods. That method, or the method that is in front of us right now, is randint. The next method is rand without the int. So let's just see what this outputs. Copy that, paste. So what this is doing here is assigning to the variable x a random integer between 0 and 100. So that's why we give it this 100 argument here. And if we want a float between 0 and 1, we don't just call the rand method without passing anything in. And again, if you want to know more about these methods, it's really simple. You just have to go to the documentation that's linked in this notebook, or I'll put on my, the description of the YouTube video. So we can make random numbers. We can also make random arrays or ND arrays. We just have to specify the size of the array that we want to make and just call both of these methods that we just used. So for example, if I want a random integer between 0 and 100 with size 5, I can pass in, this is what I pass into the argument. If I want a random float of size 5, this is what I pass in as the argument. So the arguments are different for these two methods, but you'll get used to working with them really quickly. So we see that we have random integers between 0 and 100 of size 5. And then here we have random floats between 0 and 1, and that ND array has size 5. Okay. Next, we can make random matrices, and it's simple for random float matrices, which is probably going to be the between 0 and 1, which will be our most common use case, honestly. That's kind of why I focused in on this particular type of random generator. We just pass in the dimensions of the matrix we want. So if we make a random, so we have a matrix here of size 3 by 2, so 3 rows, 2 columns. Each entry is a random number between 0 and 1. Okay. And the typical operations work as you would expect. I should probably say that, or just remind you that whenever you see this colon operation, to the colon symbol to denote all, you can slice as well. So for example, this matrix is 3 by 2, and I want to look at just, so the first column, and then I want 0 to 1. I get that one entry there. Remember that the second number after the colon is non-inclusive. So this is just the 0 entry. If I did up to 2, it would give me, so this is column 1, first two rows. So you can slice in these dimensions. Finally, random sampling. This is a common task, especially when writing reinforcement learning algorithms from scratch. You're sampling from a collection of possible choices to make decisions. And this is also, because of this, it's related to Markov decision processes, which those of you that are industrial engineering majors, you will see these often. So it's good to know how to sample, and we can do that with the choice method from the random module. So X is going to be equal to a random item taken from this list of possibilities. So in my case, I got 9. You'll get a different one unless we set the seed prior, and we'll talk about that in a later lecture. Okay, so that concludes my crash course on NumPy. There's so much more to learn, but we'll just have to see and and you'll just have to be exposed to that as we encounter it throughout the rest of the semester. But this is all I wanted
Yes,
to
sir.
cover today. All right, let me go ahead and stop the recording.